Hello everyone, our topic today is electronic configuration. This is in chapter 3. The learning outcomes, you should be able to describe the number and relative energies of the SPD orbitals for the principal quantum numbers 1, 2, 3 and also for S and for P orbitals. Describes the shapes of the s, p, and d orbitals and state the electronic configuration of atoms and ions, given proton number and charge using the convention 1s2, 2s2, 2p6, etc. We have example here. We have sodium with proton number 11. In old way, we write the configuration as 281. For neon, the number is 10. The configuration 28. For sodium, we'll see some example. We have sodium with proton number 11. The old way to construct the electronic configuration is 281. The new way, you can write for sodium 1s2, 2s2, 2p6, 3s1. For neon, number 10, the configuration in old way we can write 28. But in the latest method, we can write for neon 1s2, 2s2, 2p6. So here for sodium, we have the construction, the structure of neon, and then continue with 3s1. So we can write for sodium the electronic configuration as neon and then 3s1. The energy level of shells and subshell. How do I know that the first we need to write is 1s with 2 electrons? First, we discuss about the shell and subshell. The first shell or shell K has only one subshell S. For shell 2, the second shell or shell L, the subshells S and P. For the third shell, S, P, and D, and the fourth S, P, D, and F. And then here's the hierarchy or the step, the energy level. We choose the first, we follow the arrow here, the sign arrow, the sign arrow here, 1s and then 2s and then 2p, 3s, 3p, 4s. So you can write firstly 1s, 2s, 2p, 3s, 3p, 3d. So the order is S, P, D, and F. For S, for P, for D, for F. Like that. For example, we have magnesium here with proton number 12. Then magnesium atom has 12 protons and 12 electrons. So the configuration is 1s2, 2s2, 2p6, 3s2. For the ion, magnesium 2+, there are 2 electrons that are released. So the remaining electron is 10. 1s2, 2s2, 2p6. For aluminum, after 3s, continue with 3p1 because the number of electron is 13. So we can write 1s, 2s, 2p, 3s, 3p, 3d, and 4s, 4p. So for aluminum, 1s2, 2s2, 2p6, 3s2, 3p1. For sulfur, number 16, until this neon with 10 electrons until 2p6 here. Then we continue with 3s2, 12, 10 plus 2, and then the number of electron is 16, so the rest is 4. After 3s, then continue with 3p4. When the sulfur become negatively charged ion, S2 minus, then the sulfur atom receive 2 electrons here to be 3p6. Now we will explain why S has maximum 2, P maximum 6, and D maximum 10 electrons. There are 4 quantum numbers. The first is principal quantum numbers. This is for the shell. So in atom you have nucleus and then shell or energy level, or for according to Bohr, this is orbital. So this one is N1, shell 1, N2, shell 2, or energy level 2, then shell 3 and 3. This N is principal quantum number, or symbolized as N. In the first quantum number N, or in shell N, there is subshell. Subshell is represented by azimuth quantum number L, and the value is from 0 to 1, 2, 3, and so forth. So here for N1 or shell 1, the L or the subshell is only 0 here, because the N is until N minus 1. Then the magnetic quantum number, the value is minus L until plus L. The magnetic represents orbitals. Orbitals not the same as orbit. Orbital actually is space area around the nucleus with the highest probability to find electrons. So for first shell 1, the n is 1, the subshell only S. So L0 is subshell S. For the second shell N2, L is 0 until n minus 1, that is 1. So you have L0 and 1. L0 is subshell P and L1 is subshell P. So for the second shell you have 2S and 2P subshells. And the last one, spin quantum number S. The value is positive half and negative half. Positive half describe that the electron spin in its axis clockwise and the negative half counterclockwise. So in one orbitals maximum 2 electrons occupy the orbitals. So orbital 1s maximum 2 electron with spin plus half or clockwise and minus half or counterclockwise. For subshell P, the L is 1. Then the magnetic is minus L until plus L. So the magnetic number is minus 1, 0, and plus 1. So in subshell P, there are 3 orbitals. One orbital can be occupied by 2 electrons. So for 3 orbitals, maximum is 6. Continue with the shape of orbitals. For S is spherical, this one is S. For P has 2 lobes in 3 orientation, in axis Y, X, and Z. For this one in axis Y, so this one is orbital PY. This one in axis Z, so this one is orbital PZ. This one in axis X, so here is the orbital PX. And the last, this is for subshell D. Subshell D has quantum number L equals 2. So the number of orbital magnetic quantum number M with value minus L until plus L, minus 2, minus 1, 0, plus 1, plus 2. Then there are 5 orbitals like this. This is the name. So here you have the first shell with orbital 1s or subshell 1s, and then farther away from the nucleus you have the second shell 2s or orbital 2p and subshell 2p with 3 orbital. Then you have 3s and 3p and 3d. But the position here describe the energy level. As you can see here, the energy level of 4s is lower than the energy level of 3d. Once again, the electronic configuration for ions. For positive ion, less electrons than its atom. For negative ion, more electrons than its atom. Once again, for sodium, for atom, proton number 11. So you can follow this. You can write for sodium 11, 1s2, 2s2, look at here, and then 2p, 6, because there are 3 orbitals in subshell p, maximum 2 electrons in 1 orbital. Then continue after 2p, 3s1, but after sodium form ion positive 1 by releasing 1 electron, then the configuration become 1s2, 2s2, 2p6, because 1 electron leave the atom. Then for magnesium number 12, the same as sodium, but the last is 3s2. I wrote the 1s2, 2s2, 2p6 as neon. After releasing 2 electrons, become Mg2+, releasing 2 electrons. So here you have only 10. So Mg2+ and Na+1 ions have the same electronic configuration as 1s2, 2s2, 2p6. For sulfur number 16, this is the mass number. This is in different way to write the notation of atom. Usually we write as 16 and 32. So there are 16 electrons in sulfur atom. The first in 1s there are 2. Continue with 2s, there are 2. Then 2p6, 3s2, and the rest 4 in 3p4 here. So maximum the total number is 16 electrons. For S2 minus, receive 2 electron. So the configuration is 1s2, 2s2, 2p6, 3s2, and 3p6. You can write change this 1s2 to s2 to p6 to be neon 3s2 3p6. Right now S has 18 electrons, S2 minus ion. Orbital, once again, represented as M quantum number, magnetic quantum number, minus L until plus L. For L equals 3, this is for subshell F, this one is subshell S, L1 is subshell P, L2 is subshell D, L3 is subshell F, then the magnetic is minus 3 until plus 3. So there are 7 orbitals of D subshell. Once again, we try for carbon number 6. So the configuration is 1s2, 2s2, 2p, 2. 1s is the lowest energy level in here. Then continue with the higher energy level to S. And then 2p. In 1s there are 2. The direction here clockwise and anti-clockwise. In arrow here different direction. And into S there are 2 electrons in different spin here. And then for 2p subshell, actually there are 3 orbitals. In 3 orbitals, the electrons only 2. And then how these 2 electrons occupy the 3 orbitals in subshell P. The electron will fill the orbital single first. So 2p here single. For nitrogen with proton number 7, then the difference in here, so become 2p3, 3 electron in 3 orbitals, so single, or the spin is plus half all. Then for oxygen here, oxygen proton number 8, so 1s2, 2s2, 2p4. So there are 4 electrons to occupy 2p orbitals. There are 3 orbitals in 2p. So 4 electrons, the first 1, 2, 3, and the last here with spin quantum number minus half. So once again, we emphasize filling orbital rules. Each orbital can hold a maximum of 2 electrons. This is Paul exclusion principle. In an atom, the orbitals are filled in order of increasing energy starting from 1s. Continue with 2s. The added electron will always occupy the orbital with the lowest energy first. This is we call as off-bow principle. We summarize. Electron in atom can exist only in certain energy level, or we say as shells, outside the nucleus. The main energy level or shell that is in principal quantum number n. The value is 1, 2, 3, 4, etc. The lowest energy is n1. That's the closest to the nucleus. The shells may be divided into subshells known as S, P, D, and F, which can hold maximum 2, 6, and 10. For F, 14, because there are 7 orbitals in subshell F. The region of space in which an orbital is likely to be found is called orbital. So orbital is not an orbit, but it's a space around the nucleus with the highest probability to find electrons. Each subshell has a number of orbitals which can hold a maximum of 2. So S, subshell S, hold 2 electrons. P with 3 orbitals can be occupied by 6 electrons. D with 5 orbitals can maximum be occupied by 10 electrons. The orbitals are spherical in shape for S, and P have 2 lobes. S is spherical, P with 2 lobes. X, Y, Z axis for orbital Px, then the 2 lobes in x-axis. When 2 electrons are present in an orbital, they spin in opposite directions and are said to be paired. The quantum number is spin S, plus half and minus half, plus half for clockwise, minus half for counterclockwise. The electronic configuration of atoms is found by adding to each orbital starting from those in the lowest energy level. When electrons are added to orbitals in the same subshell, they go into separate orbital. If possible, electrons pair up when this is not possible. To master the knowledge that I have explained, you can exercise yourself by answering question 1, page 51 of the textbook. That's all for today.